Right, so I'm charging the supercapacitors, which are currently at 6.39 volts DC with 152 milliamps. My current limiter is not even coming on. So I'm below 800 milliamps. I'm less than 800 milliamps. And I'm charging at 13.97 volts. I've actually put a filter on front of the digital display because I noticed that in the previous video it was too bright and it was glaring at me. Glaring at the camera, I should say, so now you can read it a lot better. But I'm running it off these batteries, which are basically 4S lithium ion, 4S, and they're actually, you can work that out, 4.2 volts times 4, so that voltage, so we're drawing less than 800 milliamps, and the motor's been driven at 13.84 volts, which is what it's regulated and set at. The LEDs are lit because that's the power that's going through to the exit coil, and I haven't actually changed any settings, and I thought, I'm just curious. My batteries were flat. You remember in the previous video I was doing some tests and the batteries were dying on me. I thought, well, let's try this with some freshly charged batteries. So yeah, I charged up the battery, this one little bank of cells here, and I plugged it in, and I was really quite surprised actually to see 145 milliamps and over 5,000 RPM, and that the waveform, the blue waveform, is the signal that's on the exit coil. So this is the delayed pulse. It's delayed to occur at the end of the cycle on the generator cycle, but I need to delay it a little bit more, which is why I'm building a new circuit at the moment, which I've not built yet. But it's actually working very well as it is. Actually, you can see for yourself the waveform basically peaks at the end of the cycle, and it cuts it off. That's what exits the system. That's why I'm getting such a good RPM right now. So I'm getting very little drag right now, and I'm drawing 141 milliamps. Now let's see what happens if I take the load off. You'll see the LEDs go out because there's no longer a load on. Right, I've taken the load off. The speed's picking up to it's going up to about, it'll probably go up to about 7,000 RPM. It shouldn't go any faster than that really, because the voltage is limited. No, it's just got up to 6,000, about 6,800, which is not bad. Let's put the load back on, and my voltages, you can see, I don't know if you can see them. Right, let's put the load back on again. Charging. Yeah, that's a lot better, a lot less drag than before. Yeah, anyway, it's going to be fun when I get this new delay line built. Yeah, it'll be very interesting. I've been feeling a bit snivelly the last couple of days. I hope I'm not coming down with a cold. Certainly hope I don't. But let's see about this Yeah, the delay line is supposed to exert a big pulse right here really, and it's not really taking effect at the moment, but when I get the new circuit built I should be able to inject that signal much better at the right time, because I'm going to be using I've decided instead of using the passive system I'm going to use a single TRIAC to basically turn on the exit coil at the right moment. Basically the exit coil itself, as the magnet approaches, as it enters the field, will trigger the TRIAC, which will discharge capacitors that have been charged up by the generator coil, which will be sent through to repel the rotor system. So I'm going to be using the actual exit coil itself as the trigger coil, which will trigger the TRIAC, which will dump the energy out the capacitors and into the I haven't put the TRIAC on this diagram yet. I've just been doing it tonight, so I have to, but basically the TRIAC comes down here. It basically comes between this L5 is the exit coil, so it'll basically be triggering this part here, connecting that part and these capacitors to that coil. So this coil basically won't have a connection here, it will go through the TRIAC, just so you can understand what I'm doing. Now we can see the exit coil pulse more clearly, which is that little spike there. As you can see, we're climbing fast now. Well, we were climbing fast, but it's stabilised at the moment. But as that pulse gets bigger, the RPM starts climbing. Yeah, little pulse right there. As that gets bigger right there, that's when the RPM starts to shoot right up. So, yeah. So I've got my LEDs lit now, so they basically come on. They're in parallel with that 10 ohm resistor there. That's basically this here. But I haven't got all these capacitors and chokes in yet. They're coming later. I've got to move my other diagram out of the way. But look at this other capacitors. They're charged right up, look. Pretty fast. Milliamps. Yeah, just a little update. I just wanted to try it on the other batteries. So it's probably going to be next week. It will probably be next week when I can actually get the new circuit built, because I'm waiting for the parts. Stuff rattling about on here. I don't like noises. It scares me. Could be that belt sticking again. Can hear a little. Yeah. Well, trust me, if this thing won't fly back, I've got to fly apart because I've got a protection drum around the drum. But if it did, it would happen so frigging fast. The whole thing would fly off the table. Nah, I'm alright. It's just crap rattling about on this table I can hear. Yeah. So the speed is going up. current output still stable. As the speed goes up, the current output also goes up. It compensates for itself. It seems to be a constant 100 milliamps normally. So that's why I need to make some improvements to the delay line so that I can get more than 100 milliamps constant and the RPM goes up. So, because at the moment it seems to stabilize around 100 milliamps usually, and that's when I get the maximum RPM and the least losses really. But yeah. Yeah, that ringing started to show up on the scope now. Right. I'll put my LEDs in actually and see what happens. See how much minus current would take out the supercapacitors. So if I plug the LEDs back in, my LEDs are plugged in. Oh my god, we're not taking a minus voltage. Look at that, we're actually charging still. We are still charging the supercapacitors and running the LEDs right now, and I'm not even on the constant current. I'm on constant voltage still. Wow, that's pretty good. So I'm still on constant voltage. I'm on constant voltage and the yellow LED is not lit up, so I'm on constant voltage, so we're below 800 milliamps. I'm still charging the supercapacitors up, and the voltage is still climbing even though I'm running the LEDs. Well, it's going to climb a lot slower, obviously, because the LEDs are connected now, so I'm drawing some power away, but we are still definitely getting a positive charge on the current. So basically 18 milliamps are still going into the supercapacitors even while I've got the LEDs lit up, which is really quite good really. I mean, before it was minus, it would drop minus and I would see power dissipating from the supercapacitors into the LEDs to maintain it, and the generator would only provide so much. But because it's probably because I'm putting a higher voltage in on this 4, yeah, it will be. It's because I'm using a higher voltage on these 4 cells, so so higher voltage that means I'll be using less current. Yeah, it makes sense. But anyway, the voltage is limited at 13.8 anyway, so it won't go any higher than that. But that's oh, we've actually reached 12 volts now on the supercapacitors at 16 milliamps. So we're still charging. Anyway, so next week I'll try and get this new circuit built, and then my computer's gone to sleep again. So I'll just load it again. I'll load the circuit so I can show you what the changes are if I can get it up. Right. So that's my new schematic with the TRIAC. So anyway, we're going to be sorting that out next week. Anyway, I think that's about it for now. Well, hope you found it interesting.